Today we're going to talk a little bit more about trig functions. Just be aware, I did buy a new stylus and I'll be trying it for the first time today, so it may or may not go well when I try to write this stuff. Alright, so it says sometimes we are not in the unit circle. When this occurs, we choose any point in the plane and find the value of the 6 trig functions. Before we get to that though, let's do a little bit of review to help us with the new problems. Okay? It says determine which quadrant the terminal side of an angle lies given the following information. So, it tells us that sine has to be positive and cosine has to be positive. So let's go through the process. We have to ask ourselves, is sine positive in quadrant 1? The answer is yes. It is also positive in quadrant 2 with the S, because that's what the S stands for. It is not positive in quadrant 3 because only tangent's positive there. And it is not positive in quadrant 4 because only cosine is positive there. Then we move on to the fact that cosine has to be negative. You ask yourself, is cosine negative in A? The answer is no because everything is positive. And is cosine negative in S? The answer is yes because only sine is positive there. So we are in quadrant 2. For the next one, it says tangent has to be less than 0 and cosecant has to be greater than 0. Well, for the cosecant, the first thing I'm going to do is think about the reciprocal. The reciprocal of cosecant is sine. So sine has to be positive and tan has to be negative. Is tan negative in A? No, everything's positive. Is tan negative in S? Yes, it is. Is tan negative in T? No, it's not because tan's positive there. And is tan negative in C? Yes, it is. Now, sine has to be positive. Is sine positive in S? Yes. Is sine positive in C? No. So again, we are in quadrant 2. I'll leave the third one for you guys to practice that up a little bit, see if you can get that. And another thing that we've done in the past was, given the fact that you're in a unit circle, and I gave you a point, you had to find the value of the 6 trig functions. Okay, well let's practice that. In a unit circle, sine is equivalent to the y value, so it's going to be negative 4 over 5. Remember, cosine was equal to the x value, so it was 3 over 5. Tangent is equivalent to y divided by x, so negative 4/5 divided by 3/5, which is just 4/3. Cosecant, you flip the sign fraction, so negative 5/4. Secant is 5/3. And cotangent, the reciprocal of tangent, so it'll be 3/4. What this next piece is very similar. Notice I give you a point. This time, though, we are not in a unit circle. Okay? So since we are not in the unit circle, what we have to do instead is draw ourselves a triangle. So the point 724, I'm going to draw a little axis. The point 724, if I were to draw a sketch of it, would be somewhere in quadrant 1. From that point, you draw either straight up or down to the x-axis, in this case down, and also from that point, you draw from the origin a diagonal line to that point. Sorry, not the best triangle in the world. So there's my right angle. It says since the x value is 7, that means that distance is 7. And since the y value is 24, that y distance is 24. What I have to do is to find that third side to help me with the triangle. The way you find the third side is using the Pythagorean theorem. It is also a triple, but using this Pythagorean theorem will be 7 squared plus 24 squared equals x squared. And you will end up getting x equals 25. All right, now we're going to find the value of all 6 trig functions. It does say find the value of r as well. R was just that third side, realize. So all 6 trig functions, now that I have my triangle. Theta is always the angle with the origin. So sine is opposite over hypotenuse. So it's 24 over 25. Cosine is adjacent over hypotenuse, so 7 over 25. Tangent is opposite over adjacent, so 24 over 7. Secant, flip the, I said secant first. Okay, secant, you gotta flip the cosine graph, so 25 over 7. Cosecant is the reciprocal of sine, so 25 over 4. And cotangent is going to be 7/24. You are in quadrant 1. This is the last step a lot of people forget. In quadrant 1, everything is positive, so all of your answers here will remain positive. We don't have to stick negatives in any of them. Okay, I'm going to do one more with you guys, and I'm going to let you guys practice with 2 of them. Let me do the -6, -5. Okay, so I'm going to start by graphing -6, -5. Well, let me move this graph a little bit. Oops. Doesn't look like I'm going to be able to erase that. Okay, I'll do the best I can here. -6, -5 is going to be about right here. Okay, it's in the 3rd quadrant. You go straight up or down to the x-axis, and you go diagonal to the origin. The x distance, I know you see an x value of -6, please put a +6, because the distance is positive. And the y distance is +5. We will use the Pythagorean theorem to find the 3rd side. So it's going to be 6 squared plus 5 squared equals x squared. 36 plus 25 equals x squared. So you get x squared is equal to 61. Therefore, x is equal to the square root of 61. The angle we use again is always with the origin. Looking at sine theta will equal opposite over hypotenuse, so 5 over radical 61. Hopefully you're good at and realize by now that you can't have a radical in the denominator, so we rationalize, and it'll rationalize to 5 radical 61 over 61. Cosine is going to be adjacent over hypotenuse, so 6 over radical 61, which will rationalize to 6 radical 61 over 61. Tangent is going to be opposite over adjacent, so 5/6. Cosecant, flip the very first fraction here, this one, okay? And that's going to end up being radical 61 over 5. It's easier if you flip the first one in this case. Secant, flip the cosine fraction. Again, it's easiest if you flip the first one. And cotangent, flip the tangent fraction 6/5. Finally, we go back. And we see we're in quadrant 3. In quadrant 3, tangent and cotangent will be positive. Everything else we need to stick a negative in front of. So sine, cosine, cosecant, and cosecant. At this point, I would like you to try the problems that we skipped.